In question 1, we are given a dot plot that shows the distribution of daily rainfall in millimeters at a weather station for 30 days in September. In part AI, we are asked to write the range of this distribution. This question is worth 1 mark, which is going to be an answer mark for the correct answer. To determine the range of this distribution, we need the minimum data, the minimum score, which is 0 millimeters, and the maximum score, which is 17.8 millimeters. So the range equals the maximum value take away the minimum value, which is equal to 17.8 millimeters in this question. In part 2I, we are asked to write down the median of this distribution. This question is also worth 1 mark, which is going to be an answer mark for the correct answer. Recall the fact that the median is the score in the middle. So if we have 30 days, there are 15 scores before the median and 15 scores after the median. So what we need the 15th score, and in our case this is 0 millimeters, and the 16th score, and this is 0 millimeters as well. Now we can calculate the median, which is the average of these two values, so we end up with the median being 0. In part B of this question, we are asked to circle the data point on the dot plot given that corresponds to the third quartile Q3. This question is worth 1 mark, which is going to be an answer mark for the correct answer. What we need for the third quartile, we need the 15 scores on the right-hand side of the median. So we have 15 scores, which means 7 scores are before Q3 and 7 scores are after Q3. So if we start at the right-hand side and we count 8 points, then we are going to find Q3. 1, 2, 3, 4, 5, 6, 7, and 8 is Q3, which is 2.6 millimeters. In part CI of this question, we are asked to write down the number of days on which no rainfall was recorded. This question is worth 1 mark, which is going to be an answer mark for the correct answer. No rainfall means 0, so we count the number of dots above 0, and that is 16 dots, which means 16 days. In part CII, we are asked to calculate the percentage of days on which the daily rainfall exceeded 12 millimeters. This question is worth 1 mark, which is going to be an answer mark for the correct answer. Above 12 millimeters means greater than 12, so we look at the dot plot at the 12 millimeters. Above 12 there are 3 dots, which means 3 days. 3 days out of the 30 days for the month, we can calculate 3 over 30 times 100, which equals 10%. In part D of this question, we are asked to use the grid given to construct a histogram that displays the distribution of daily rainfall for the month of September. We are also told to use interval widths of 2, with the first interval starting at 0. This question is worth 2 marks. 1 mark is going to be for the use of the 2-unit widths, and the second mark is going to be for the correct column. Make sure that you read this question properly. So, interval widths of 2. So first of all, we start between 0 and 2. We count the number of dots. There are 21 dots, so 21 days. Next, we look at the interval 2 to 4. There are 3 dots, which means there are 3 days. So now we can draw this column as well. Then we are going to look at the interval from 4 to 6. From 4 to 6, there are no dots, which means we are not going to have a column between 4 and 6. And the last one is between 16 and 18. There are 2 dots, which means 2 days. So now we can draw this column on the histogram as well. From the VCAA examiner's report, be very careful. Many students inappropriately drew columns with interval widths of only 1. So make sure that you read the question properly. In question 2, we are told that the weather station also records daily maximum temperatures. In part A, we are given the 5-number summary for the distribution of maximum temperatures for the month of February, as shown in the table. We are also told that there are no outliers in this distribution. In part I of this question, we are asked to use the 5-number summary given to construct a box plot on the grid below. This question is worth 1 mark, which is going to be an answer mark for the correct box plot. Let's start with the minimum value. The minimum value is 16. We plot this on the grid, and then we continue with the first quartile, Q1, which is 21. And then we have the median, which is 25. The next point we are going to plot is Q3, the third quartile, 31. And the last point is going to be the maximum value, which is 38. Now that we have the 5 points on the grid, we can easily construct the box plot as shown. In part 2i, we are asked about the percentage of days that had a maximum temperature of 21 degrees Celsius or greater. This question is worth 1 mark, which is going to be an answer mark for the correct answer. Since 21 degrees Celsius is the first quartile, this means that in 75% of the days in February, the maximum temperature was 21 degrees Celsius or greater. Just a note from the VCAA examiner's report, a common incorrect answer was 25%. In part B of this question, we are given 2 box plots that display the distribution of maximum daily temperature for the months of May and July. In part I, we are asked to describe the shapes of the distributions of daily temperature, including outliers, for July and May. This question is worth 1 mark, which is going to be an answer mark for the correct answer. So let's look at July. The July distribution is positively skewed with an outlier. From the VCAA examiner's report, it is noted that common unacceptable answers for July included symmetrically skewed, evenly distributed, bell-shaped, and normally distributed. For the month of May, you can see that this is symmetric with no outliers. In part 2i, we are asked to determine the value of the upper fence for the July box plot. This question is worth 1 mark, which is going to be an answer mark for the correct answer. To calculate the upper fence, we use the formula Q3 plus 1.5 times IQR. IQR equals Q3 minus Q1. So from the box plot, we can see that Q3 equals 11 and Q1 equals 8. So IQR equals 11 minus 8, which is 3. We can now calculate the upper fence, which is equal to 11 plus 1.5 times 3, and this gives us 15.5 degrees Celsius. In part 3I, we are asked to use the information from the box plots to explain why the maximum daily temperature is associated with the month of the year. Quote the values of appropriate statistics in your response. This question is worth 1 mark, which is going to be an answer mark for a correct explanation. A correct explanation would include either the fact that there are different medians, 9 degrees Celsius in July and approximately 14.5 degrees Celsius in May, or different IQRs, 3 in July and approximately 6.5 degrees Celsius in May. Here are some notes from the VCAA examiner's report. The answer needed to refer to the difference between the two median temperatures, simply quoting the two medians' values, was not sufficient. It appeared that some students confused maximum daily temperature with the maximum of the box plot, and some students refer to average or mean temperatures. However, this cannot be accurately determined from a box plot unless the distributions are clearly symmetric. The data displayed in the table in question 3 shows a sample of actual temperatures and apparent temperatures recorded at the weather station. A scatter plot of the data is also shown. The data will be used to investigate the association between the variables apparent temperature and actual temperature. In part A of this question, we are asked to use the scatter plot to describe the association between the apparent temperature and actual temperature in terms of strength, direction, and form. This question is worth 1 mark, which is going to be an answer mark for the correct answer. By looking at the scatter plot, we can tell that this is a strong, positive, and linear association between the apparent temperature and the actual temperature. From the VCAA examiner's report, a relatively common incorrect response was strong, linear, and positively skewed. In part BI of this question, we are asked to determine the equation of the least squares line that can be used to predict the apparent temperature from the actual temperature. Write the values of the intercept and slope of this least squares line in the appropriate boxes provided. Also, round your answers to two significant figures. This question is worth 3 marks. 1 answer mark is going to be given for the correct gradient, a second answer mark is going to be given for the correct intercept, and the third answer mark is going to be given for these two values written to two significant figures. Using available CAS technology, open a spreadsheet and in the first column enter the actual temperature because this is the explanatory variable. It's on the horizontal axis of the scatter plot. In the second column, enter the apparent temperature because this is the response variable on the vertical axis. Then we can calculate the intercept, which is negative 1.65 or negative 1.7 to two significant figures, and the slope is 0.94 to two significant figures. From the VCAA examiner's report, consider that there was much evidence of confusion between decimal point rounding and significant figure rounding. Many students rounded to 2 decimal places rather than 2 significant figures as required. Here is an example. Number 0.9 has only one significant figure, which is 9, whereas 0.90 has 2 significant figures, which are 90. In part 2i of this question, we are asked to interpret the intercept of the least squares line in terms of the variables apparent temperature and actual temperature. This question is worth 1 mark, which is going to be an answer mark for a correct answer. From the equation of the least squares line, the intercept means that, on average, when the actual temperature is 0 degrees Celsius, the apparent temperature is negative 1.7 degrees Celsius. From the VCAA examiner's report, consider the fact that a common incorrect answer confused intercept and slope, and another common incorrect answer mixed up the variables. Always remember that the variable on the horizontal axis is the explanatory variable, in this case the actual temperature, and the variable on the vertical axis is the response variable, in our case apparent temperature. In part C of this question, we are told that the coefficient of determination for the association between the two variables is 0.97, and we are asked to interpret the coefficient of determination in terms of these variables. This question is worth 1 mark, which is going to be an answer mark for the correct answer. The correct answer here is 97% of the variation in the apparent temperature can be explained by the variation in the actual temperature. From the VCAA examiner's report, some students mixed up the response variable and the explanatory variable in this statement. Also, it's the use of was due to rather than explained by. So the expression to be used is explained by and not was due to. In part D of this question, we know that the residual plot obtained when the least squares line was fitted to the data is shown below. In part I, a residual plot can be used to test an assumption about the nature of the association between two numerical variables. The question is, what is this assumption for this set of data? This question is worth 1 mark, which is going to be an answer mark for the correct answer. The assumption here is that there is a linear association. In part 2i, we are asked, does the residual plot above support this assumption? Explain your answer. This question is worth 1 mark, which is going to be an answer mark for the correct answer. The answer is that the random pattern supports the linear association. From the VCAA examiner's report, we are told that reference to a lack of pattern or the randomness of the plot was required. An unacceptable answer was that the points are all scattered evenly above and below, with no mention of randomness. So basically, the randomness or the lack of pattern were required here. The time series plot given in question 4 shows the minimum rainfall recorded at the weather station each month plotted against the month number. For example, 1 represents January, 2 represents February, and so on. The rainfall is recorded in millimeters, and the data was collected over a period of 1 year. In part A of this question, we are told that the 5-median smoothing has been used to smooth the time series plot above. The first 4 smoothed points are shown as crosses. We are asked to complete the 5-median smoothing by marking smoothed values with crosses on the time series plot given. This question is worth 2 marks. 1 mark is going to be for any 2 correct points, and the second mark is going to be for all correct points. The first cross we need is for month number 7. Because it's a 5-median smoothing, we need 2 points to the left of 7, the point at 7, and 2 points to the right of 7. And then we determine the median on the horizontal axis and the vertical axis. At the intersection between these lines, we put the cross. Now we follow the same procedure for month number 8. So 2 points to the left of 8, the point at 8, and 2 points to the right of 8. Now we find the median on the horizontal axis, the median on the vertical axis, and where they intersect we have the cross. We follow the same procedure for month number 9. So 2 points to the left of 9, 1 point at 9, and 2 points to the right of 9. The median on the horizontal axis and the median on the vertical axis, and at the intersection we have the cross. And we follow the same procedure for the last month, which is number 10. 2 points to the left of 10, 1 point at 10, and 2 points to the right of 10. Now the median on the horizontal axis and the median on the vertical axis. And now we have the cross. Now we connect the points with the rest of the smooth data. Here is a note from the VCAA examiner's report. Median smoothing is a graphical technique and requires some accuracy in the correct placement of crosses or dots. Many students did not answer this question. The maximum daily rainfall each month was also recorded at the weather station. The table below shows the maximum daily rainfall each month for a period of 1 year. The data in the table has been used to plot the maximum daily rainfall against month number in the time series plot below. In part B of this question, we are told that 2 mean smoothing with centering has been used to smooth the time series plot above. The smoothed values are marked with crosses. Using the data given in the table, we are asked to show that the 2 mean smoothed rainfall centered on October is 157.25 millimeters. This question is worth 2 marks, 1 method mark for an appropriate method used, and 1 answer mark for obtaining the correct answer. Because we are looking at October, we calculate the mean for the months of September and October. That is 124 plus 140, all divided by 2 equals 132. Then we need to calculate the mean for October and November, which is equal to 140 plus 225, all divided by 2, and that gives us 182.5. To center this data, we need to calculate the mean of the 2 means. That is 132 plus 182.5, all divided by 2. And this gives us 157.25 millimeters as required. From the VCAA examiner's report, we are told that the data needed for these calculations should have been taken from the table rather than from the graph. And many students did not answer this question.